So we're now going to look at module number 9, which is the address resolution protocol. The objective is we're going to be looking at the media access control and IP addresses, what the address resolution protocol is all about, the neighbor discovery protocol for IP version 6, and how it operates. So as we explained in the previous chapter, two fundamental addresses that are needed for devices to communicate are the layer 2 physical address or the MAC address. Now, normally this is used for network card to network card communications on the same network. So remember, when devices are communicating together and they belong to the same network, their frames are sent to the switch. The switch bases on the MAC addresses to know which ports to forward the frames to. Remember, at the end of those ports where the switch is forwarding the frames are the destination device. So it makes the decision based on the media access control addresses or the physical address. The second thing we have on a PC is the logical address or the layer 3 address. Now this one is normally going to be used to send packets from the source device to the destination device. So normally when devices are communicating, they will have both sets of information within the frames that they are sending. Remember, at layer 3, as part of the encapsulation process, the source and destination IP address are added. And when this goes to the layer number 2, the link layer, that package with those logical addresses is then encapsulated into what they call a frame. And part of the encapsulation of the frame involves adding of the physical addresses. Okay, so layer 2 addresses are normally used to deliver frames from one network card to another. That is physical addresses. If a destination IP address is on the same network, the destination MAC address will be that of the destination device. So you have MAC address of source, IP address of source being sent to MAC address of destination and IP address of destination. So normally when it comes to those frames that are being exchanged, they'll have both those types of addressing. One has been added on the link layer, that is the physical address, and the other one was added at the network layer, which was the IP address. Now, when the destination IP address is on a remote network, destination media access control address is that of a default gateway. As I discussed in the previous chapter, if the data is being sent on the same network, it will be forwarded to the switch. The switch will use the MAC address of the source and the MAC address of destination. However, if data is going outside the network, the PC or the device needs to be able to communicate to the default gateway. Remember, the default gateway is that interface of the router that's part of your own network. So for that reason, to be able to communicate with the default gateway, it will be the MAC address of the gateway that will be put in the destination part of the frame, just so that the PC can communicate with the router. Remember, to communicate with the device on the same network, that is the default gateway itself, only physical addresses are used to identify source and destination. For that reason, you will find that if a system is going to be communicating outside the network, to be able to communicate outside the network, the destination MAC address has to be that of the default gateway, so that the frame can actually get the default gateway, which will then send it out. Remember, the default gateway is a router, and it will only make use of the network layer addressing, that is the IP address, to be able to forward the frame to the next device. So the address resolution protocol is used by IP version 4 to associate the IP version 4 address of a device with the MAC address of the network interface card. When it comes to IP version 6, the Internet Control Message Protocol version 6 is used by IP version 6 to associate the IP version 6 address with that of the device's media access control card. So the network card, that is the network interface card. Now, I will, at the end of this chapter, I'll set up Packet Tracer and show you how all this works, show you how you can identify the MAC addresses and also the IP addresses. So how do you do it on a normal computer? You simply open up your command prompt and simply run the command ipconfig all. Let me quickly show you here. You simply run the command ipconfig all. Let me remove this here. So I open up my command prompt and run the command ipconfig with an all. Now here I can see my physical address over here, and then I also see my IP address over there. So that's the physical address as well as my IP address. So what is ARP? ARP in full stands for the Address Resolution Protocol. It is used to determine the destination MAC address of a local device when it knows an IP version 4 address. ARP will provide two basic functions. The first one is resolving IP addresses with respective MAC addresses, and the second one is maintaining what they call an ARP table. This is simply a table of IP version 4 address to media access control address mapping. So it maintains a mapping of IP to physical addresses. So to send a frame, a device will search its ARP table for a destination IP address and the corresponding MAC address. If the packet's destination IP version 4 address is in the same network, the device will search the ARP table for the corresponding destination IP version 4 address. If the destination IP version 4 address is on a different network, the device will search the ARP table for the default gateway. Remember, it has to send anything going out of the network to the default gateway. For that reason, it has to use the MAC address of the default gateway. If the device, if the device locates the IP version 4 address, its corresponding media access control address is used as the destination MAC address of the frame. And if there's no ARP table entry, if there's no ARP table entry, then the device will send a broadcast. It will send out an ARP request. So I will show you quickly here how an ARP request looks like in Wireshark, and you get to see how it looks like. So in my Wireshark here, if you see closely, these are what they call ARP requests. All these hook queries, if you see here in the columns ARP, and these are all ARP requests. Normally they are sent as broadcasts, and if you see here, this PC here is sending ARP queries. Who is this? And so on and so forth. It's looking for the MAC address. Okay. And when it gets the MAC address, it uses that to build the ARP table. So how do you get to this? Maybe the big question. You simply go to the ribbon on here and choose Ethernet broadcast and press enter. Yeah, you go there, you press enter, and you just give it a minute, you'll be able to get ARP requests. So let me first clear this. So let me recapture. So I'm running a capture. So you see I've run it again. Now I go to the over here, the ribbon, and I choose Ethernet broadcasts. I press enter, and then you just give it a minute, you'll be able to see ARP broadcasts. Just give it a minute. See here. Just a second. So these are ARP broadcasts. Okay. So you just give it a minute and it begins searching. So if there are any broadcasts, you'll be able to display and see the output. So here, as you see, I now have queries for ARP. You see the protocol type is ARP, and these are all ARP requests. Okay, let's continue. So within your notes, there's a video that covers how ARP requests for MAC addresses and so forth. This you'll find within your notes, as well as a video explaining to you how ARP requests are responded to. So I'll also show you that when I make a packet tracer scenario. So normally your PC will maintain something called an ARP table, and it will contain all the MAC addresses and IP addresses of the devices that your system has been communicating with. And in case the system needs to communicate to them in the future, you should look at its ARP table so that you can find out the MAC addresses that commonly communicated with systems. So entries in the ARP table are permanent and can be removed when an ARP cache timer expires or after a specific period of time. The duration of the ARP cache timer will differ depending on operating systems. Different operating systems, Windows, Linux, they have different retention times. The ARP table entries can also be removed manually by the administrator. The command that we use to view the ARP table of your system is ARP-A. So I'll quickly show you that on my command prompt here. So the command I will use, I'll first clear the screen, to view my ARP table is simply ARP-A. Now you see here I have my ARP table, but it only contains the gateway. So the equivalent in Linux, which I'll show you here, on Linux machine, I'll clear the screen. Control L. I simply run the command ARP-A. So as you see, this Linux system has been communicated with many systems on different VLANs, and each of them you see the IP address and the respective mapping of the physical address. Okay, so whenever a system needs to communicate with any system, it looks at its ARP table, finds the MAC address of that device, and is able to communicate with it. So ARP requests are received and processed by every device on the network. Why? Because any message that is sent and received by all devices is called a broadcast. Now, excessive ARP broadcasts can cause a reduction in performance because they create congestion, and there's also a very big risk with ARP as a protocol, because ARP replies can be spoofed by a threat actor to perform what they call an ARP poisoning attack. However, enterprise level switches include mitigation techniques that protect against ARP attacks. So the end goal here is that a hacker will intercept an ARP requesting for your default gateway, and then the hacker's system will respond to your system with the wrong MAC address of a default gateway. And this normally leads to other computers all sending their traffic to the hacker's system because they've been lied that it's the default gateway because of ARP poisoning. However, switches provide techniques whereby they prevent any system from claiming that it is a default gateway by providing techniques that protect the default gateway. So within your packet tracer, I'm also going to show you how ARP request looks like. We'll also be looking at examining how a switch MAC address table looks like, as well as the ARP processing remote communications. I'll set up a topology that demonstrates this. Now with IP version 6, it does not use ARP as a protocol because ARP as a protocol is commonly used in IP version 4. Now the IP version 6 uses what they call the neighbor discovery protocol. Neighbor discovery protocol will provide some of the features of ARP, for example, address resolution, error discovery, and redirection services. The ICMP version 6 neighbor solicitation and neighbor advertising messages are normally used for devices-to-device messaging, such as address resolution. So with ICMP, we have what they call the neighbor discovery protocol. Now, this one will provide for messages called the neighbor solicitation and neighbor advertisement messages. Now, in this case, when you have computers that have been configured with IP version 6 addresses, they will send messages out on the network to try to discover if there are any IP version 6 devices on the same network as themselves. Now, when they discover each other, they exchange messages and they're able to configure themselves given that they have an understanding of each other. So this enables the devices to know each other's MAC addresses, physical addresses, and so on, as well as the IP addresses they own, because they're able to look out and and discover each other. Then we also have what they call the router solicitation messages and router advertisements. These ones are normally used for messaging between devices and routers for router discovery. So in addition to discovering the neighbors, IP version 6 devices are also able to discover the routers on the network, and they'll make use of the router solicitation and router advertisements. And lastly, we have the ICMP version 6 redirect messages. These ones will normally be used by routers for better next hop selection. So routers are also able to discover each other and discover which are the better routes that they can use. So with IP version 6 redirect messages, routers will use them to select the next hops, that is the next routers that through which they can send traffic. So IP version 6 devices will use a neighbor discovery protocol to resolve MAC addresses of a known IP address, and neighbor association messages will be sent using a special Ethernet and IP version 6 multicast address. So I'll quickly show you in Packet Tracer how this is done at the end of the chapter. So now let me show you how this works. So I'll open up my Packet Tracer and quickly show you how the address resolution protocol works, how the MAC addresses are maintained, and then I'll show you situations whereby we have a gateway. Okay. So first thing I will do here is I will get out my router, an 1841 router. I'll get to 2960 switches. And then, of course, I'll get 4 computers. So I'll be fairly fast because it's something we've done in the last chapter. So I'll connect them, switch, then the router to the switch. I've used any port, so it doesn't matter which port that you use. So I could say that this network on this side is that, and then you saw this network. So this network on this side we can say is maybe the 192.2.0, while this one is there. Okay, now let's quickly do this. So next step is let's configure the PCs with the IP addresses. Well, let's begin with the router first. So always please remember that when the router asks you to begin auto configuring, first thing you say is no. Then we get to our privilege exec global configuration mode, figure terminal. So we configure the first Ethernet 0/0 with the IP address 8.1.0, no shutdown. So I've configured first Ethernet 0/0, which is on the network on the left, and then exit out of that interface, go to the next interface. and I issue an IP which belongs to the 3 network, and also no shutdown. So if you look at this closely, you'll see the router interfaces are now green, and the IPs have been set. So if I can explain better, this is the 2 network. So for that reason, the interface on this side past Ethernet 0/0 has been given a name with the IP address 192.168.2.1. So this here is the 3 network. So they connect on fast Ethernet 0/1. So for that reason, fast Ethernet has been given an IP address that belongs to the 3 network for the network on the left. So let's prepare and give our PCs the IP addresses. So PC's IPs, PC on the network on the left, I give it an IP address 192.168.2.2, and the gateway is the IP address of the router. And then go to the next PC. Dot 3 192.168.2.1. So all of them need the router to connect out to the network. And I go to this network here, which is the 3 network. I say 3.2, 3.1. 3.1 is the IP of the router that belongs to this other network. Give it an IP. Then a gateway. Okay, so let's try our ARP and see what happens. So from this PC, I will try to ping every PC on the network, and then we'll see what exactly happens. I say ping 192.168.2.2.3, sorry, which is the other PC on the same network. Okay, then let's try the remote networks. 3.2. 3.3. Okay, so let's run our ARP command. So if you notice here, 192.168.2.1, that's the MAC address. 192.168.3.1, that's the IP address. So this here is the MAC address table. Okay, so you can go here, ARP-A. It has the address of the default gateway. You could also try to ping. Okay, look at the ARP table, and that's it. So you only see the default gateway because this system, you only see the MAC address of the default gateway because it's only communicating with remote addresses. That is only communicating with devices that are out of its own network. That's why it has the default gateway MAC address saved. And that's all for me for this chapter. And yes, so you can make use of Wireshark as well as your command prompt to be able to verify the various ARP commands and viewing the table and so on.